So I would ask David to host the discussion session.
I have a question. Well, I have a couple of questions, but my first one's for Tony, kind of because it's in my head, because it was the most recent presentation. I'm really interested in your approach because you're kind of doing exactly what I would do. You didn't have sufficient level of control over the genetic algorithm interface you were using, so you built your own one. This is one of the things that can be quite frustrating, where you have a system that is channeling the way that you have to use it, and you've tried to free yourself from that. What I'm interested in is when you were doing, I didn't understand every single one of the process you're using, but when you were doing these, how did you decide on the evaluation parameters? And how do you avoid being reductive in this? Because you need to choose some measure of success, but often in systems, measures of success are very complex because there's many, many things you have to consider. So how did you approach that?
Yeah, so I think when I originally wrote this paper, I had a lot more in my mind, but there's kind of these kind of three defining things. So the first one was the exploitation, which is common. So I could easily look up the best ways of measuring that performance because they already existed. Then there was the exploration. These were a lot more lackluster. So the way I did that was I just literally said, with the design's intent, how did something come out that was unexpected? Which seems very simple, but that's the only way I could see it. And so what I had to do was bring in a third study model, which was my friend, who knew nothing about genetic algorithms, but has his own design project, has his own intent, and then he could feedback that to me. So I think in my original paper, I discussed a lot. I discussed a lot more about that. Off the top of my head, I don't really remember. Sorry. And then the third one was just as a tool, I guess, because I've never created my own tool. I just kind of did it just because I wanted to see if I could do it, and I guess I did it. So that was the kind of outcome of it.
Yeah. Okay, yeah. Thanks. I do have another question for you, but I kind of think I should be fair on everyone else. I have a question that's kind of really for all of you. So you're all using these very complex algorithms. You're using convolutional neural networks, machine learning, genetic algorithms. And how do you know when you have a good solution? How much of it is your subjective judgment? And if it's not just your subjective judgment, how do you know if the system has just failed to produce a good solution? You know, there's always a level of trust in the system that you've built. So how do you trade off all of that?
I still don't have confidence that I've exactly made a tool that works in terms of the exploration. So I could argue with a few of the results I've achieved, but I still would like to develop it more just to kind of prove even further, to have even more of a backbone when I answer the hypothesis.
Well, one thing that I think was particular in your case, Tony, was that you exposed some issues with the solution you produced, and there was one of them where you had, I can't remember, you had many, I think it was over 500 permutations to test, and you decided you were just going to test some subset of these, and so there was quite a lot of judgment. Your judgment is entering into the process, and so where you expose these issues for the solutions produced, and you go back and you redesign your genetic algorithm. In a sense, you're becoming part of the computation there. Is there a way to remove the system's dependence on your judgment at what are essentially intermediate stages, and automate the whole process?
I mean, if I understand correctly, I actually saw it as a benefit in the sense that as I'm designing this algorithm with the tool, I'm trying to have a back and forth using my own intuition as a designer to improve it. So in that case, it wasn't necessarily a fault. It's more of a, as I'm using this tool, I'm learning about my own design process.
Sorry, I'm not suggesting that any of this is a fault or
okay.
I'm just trying to get your impression of it. because the outputs of all these algorithms, this applies to everybody. These are for systems that are people are going to use. Ultimately, we're designing systems for people, or we're designing buildings for people or spaces for people. So at some point, yes, but when you're altering and you're trying to use these complex tools, in some sense, what we're trying to do is automate a lot of the design processes and get computers to do a lot of the work for us. And where you have to step in the middle, it requires expert understanding. You were able to go in there, you designed this genetic algorithm yourself. Most people would look at it and wouldn't have the faintest idea what to do. So it's very dependent on you. So I guess what I'm asking is, can you design these sort of meta tools that will run the whole show for you?
I think this also reflects on Melinda's presentation. That because you do mention quite a few times, human logic versus machine logic. So I just wonder, what is the real difference, because that logic is created by us, and it can often be a playback. Does this make sense?
Yeah, absolutely. And I just wanted to add to Tony's comment and David's question, that it's really rare when you're fully aware of your tools. So it's like when you're talking and you're aware of your thoughts, basically. But as architects, we're usually using somebody else's tools and other softwares developed by somebody else for designing approaches. And I would be also so curious if it makes any difference for you, or how did you decide to just create or having your own apparatus or your own medium to communicate through? So wasn't it enough to use other mediums, or it is more apt for you? So and also you said at the beginning that the architectural design solution is an approximation, so you can never know if it's good or bad, but basically if you're designing a building, you also never know if it was good or bad, just people start to use it, and hopefully it was sufficient at least. And maybe the same with softwares or algorithms, that you try to do your best and hope it will be enough.
Sorry, you go, Abel.
I politely disagree, Melinda. I think we do know, especially as an architect, I've been designing buildings now for a good 20 years, I think. And I do know when I see a bad building. And also I think we all know when we see a bad piece of software, when you want to do something, but it seems like things get more difficult than actually easier. And there's always like a struggle to use the tool. But I think I'm just thinking about David's question about handing over control to a black box, to that thing of running the show. Let a genetic algorithm or a neural net to run the show when it's so hard to measure certain things. But there is always a gut feeling. Is that something that we can say? Is David, am I in the right track, or am I diverging?
I think you are, but it's a complex thing. So the idea of software tools that will the process of automation has a tendency to produce things that are all the same. It's not essentially true that we can have a gut feeling, and all your gut feelings about buildings are probably better than mine, because you probably spend much more time thinking about this. But even then, we all have our own biases, and our biases are thereby what our expectation of what a building is, or what it should be, or what it should look like. And I do wonder, so Melinda, do you think that the approach you're taking with the sort of AI approach is to try and escape from these patterns of thinking and just establish some new territory? Is that part of the idea here?
It's a tough question, and basically escaping, but maybe these new tools or new approaches to design shouldn't be compared to previous ones. So maybe it's totally different. So it's not that, so it cannot be compared to gut feeling or human intention, but because it's basically based on data and calculations. So more proved, let's say. So I would consider them more straightforward and not this insecure or arguable, because you can prove anything based on, yeah, I have measured it or calculated, or the computer did it, and then it's just easier to argue with it, I would say.
Okay.
And Guillermo, do you have any views on this?
Yeah, again, for me, as long as the system is dependent from a human to be architectured with, there is always going to be a chance for, you can never trust it. There's always going to be a human error impact, because humans do errors, and subsequently the systems are produced by us. So it's not that the system makes a mistake, it's that we hadn't thought about this scenario, and that's how the mistake is going to be produced. So as long as systems cannot learn of their own and they are dependent on us, I think that there's always going to be a risk for error. We just try to minimize it to as little as possible.
Okay, I think, certainly I think I agree with you in your case, because you have a very, it's quite a tractable issue that you're looking at. So for example, you're looking at taking a look at what the exploring the outcomes of a natural disaster and its effect on something. So the only errors can be in your modeling parameters if there's some mistake in that, but you know what it is that you're trying to mitigate against. So in terms of evaluation, it's a bit more straightforward. You know what you're trying to avoid. You're trying to avoid damage to the building or people being hurt or something like this.
There is a possibility of error too, because you never know the generally from a disaster, you can never know the impact on the building, because the building is never as you designed it. So you might have designed it like 10 years before, and you have find a scenario of what was going to happen if it was struck by a seismic station 10 years before, but you don't know what's going to happen 10 years later, how the elements were within, are they corroded, or something else has happened to the building. So yeah, that could be like an uncertainty there.
Okay. I'm just looking at the side panel here. I don't see any other questions there. Do you have another question, Abel?
No, I'm just grateful for all of you to present today, like different ways to think about different problems or similar problems. I don't see any questions. There was an earlier question, but was about an interest on Silicon Valley's interest in augmented reality as a replacement for mobile phones. But I think this is related to your presentation, David.
I think I saw this question. So this is from Mark Corrigan. These are always really tough questions to answer. You know, is it should I put my money in this? And this goes with the kind of cycles of hype and disappointment. You know, we've all seen. You know, HoloLens does some interesting things, but it's still, you know, it's not. I think there was something about HoloLens in there as well. Yes, there was the Microsoft mesh tool. The brochure looks great. But when you put these on, there are issues with lighting, with the narrow field of view. So they're great. I mean, the HoloLens is a fantastic piece of engineering. I'm not going to argue with that. And then there was Magic Leap, which we've not heard from for a while, which was it didn't deliver what it promised. It managed to achieve better levels of contrast by shutting out natural light. So it was effectively a headset with a sunshade on it. Where AR is going, it's hard to know, because people are always innovating, and if people have really good ideas, they're going to go somewhere. We possibly haven't heard about them yet, because they'll be keeping them very close to their chest. So there's certainly, yes, I'm sure there's lots of resources being invested in this. It's a problem that if you can come up with a good solution to this, then you will get a return on these investments. But whether that's actually happening, I can't say.
Yeah,
I would love to know.
Yeah, it's hard to predict. What I see, and what I've seen also from Bartlett master students and PhD students, is something that it's becoming easier to prototype augmented reality and VR. It's certainly more accessible, and it seems to be becoming a great platform to publish content. And we kind of understanding, especially in the Bartlett architecture world and other places, ETH and the Architecture Association, we see the research population, mastering content, content creation for VR and AR in a way that we did not see just a few years ago. So yeah, definitely lots of things happening. I think there's lots of interest on how to use this kind of virtual environments for education and training. But I think all of it is kind of work in progress. It has progressed a lot, but all of it is a work in progress.
For sure, yeah. I mean, as I say, during lockdown, we as a group spent a lot of time wearing headsets and communication with other, and just exploring these platforms. So in a way, I guess that was one of the upsides of this. We would never have found the time to do this otherwise. And it has been quite eye-opening, actually, quite how good and how well these social VR, collaborative VR systems work now. I'll say they're not perfect. They're not great for everything, but they're certainly, these definitely fall under the category of usable systems. So the idea of doing something like distributed design review is completely feasible.
May I ask one question for David?
Of course.
Sorry about that. Yeah. Okay. Everyone is speaking about virtual realities, augmented realities, and stuff. How about the mixed realities aspect? Like, what do you think is going to lead somewhere? Are we going to use it more than the others?
Okay, so that's an interesting question, because there's always, people will talk about virtual reality, augmented reality, mixed reality, and these are all things. I wouldn't necessarily say they're on a continuum, but when you talk about mixed reality, you're mixing virtual elements with real elements. So do you mean that in the respect as to what the HoloLens does, or are you talking about?
So the way I understand mixed realities is that you can integrate everything together in one environment. You can have virtual environment, or the real environment, and augmented elements within the environment.
Yeah.
And you can manipulate the environment the way that you see fit, as if you were in a real environment with real objects.
Mm-hmm.
And you could move them around however you want.
Yeah, you can certainly do it. I mean, this is in some ways respects, this is a way of getting other kind of realistic sensory modes in there. So for example, haptics is very, very hard to do with VR. You know, we have these force feedback robots that are unwieldy, they're expensive, and you know, they give you the sense of force or weight or solid objects. On the other hand, you can do things like just stick real objects in there and have people picking up real objects, and these are tracked and they will see them as some virtual element, and you can put them down somewhere else. So you can mix the sensory modes in that way, or you can just simply have, you know, something like you'll have with the HoloLens, where you put in virtual elements and you mix them into an environment. So you know, if it's if you're looking at a building, you can walk around a real building and see it as it is planned to be redeveloped, or you can see it as you can maybe see it as it was in the past. You know, you can use this for historical tours. So these things work. It depends what you want to do with them, and the display technologies for them are not perfect yet. You know, they're good algorithms. So things like SLAM for scanning the environment around you, working out where things are, so that when you take a virtual element and you put it in, it will rest accurately on top of a real object. But trying to get these to work across varying lighting conditions, trying to get these to display in varying lighting conditions in a way that you can see them, all these things are still very, very challenging. And of course, the whole idea of using waveguide technology that HoloLens and other headsets use to operate over anything other than a very narrow field of view is you know, a really, really challenging problem to overcome.
Yes.
Thank you.
Okay. So I would like to thank you all for presenting today. Thank you, Tony, Melinda, and Guillermos. And a special thanks to David for hosting this session. And we will go into our lunch break and come back at 2:00 sharp. We start our second session on cognitions and computational design. So, unless you have any further thoughts or notes, we'll go into the break. And yeah, thank you very much for the very interesting papers and for participating today.
All right. Thank you, Abel, and thank you, Tony, Melinda, and Guillermos.
Thank you all very much. Thank you.
Thank you all very much.
Cheers. Yeah, see you at 2:00.
Yeah, for lunch. Bye-bye.
Yeah.
Bye-bye.
Cheers.